In class 10th, based on ISC pattern, I am taking the topic, the characteristics of the sound. This is a chapter 7C of the book. There are three characteristics. Three characteristics of sound. Number one, loudness. Number two, pitch. And number three, quality. Now here we will discuss one by one. So first I am taking the loudness of sound. Loudness of sound. So this is the characteristic which distinguishes the two sounds which have the same frequency and the pitch and also the intensity. The characteristic which distinguishes the two sounds of same frequency and pitch is called loudness of sound. So sound, or we can say better that this is the property which sound that if suppose there is a sound which are having the same frequency and the same pitch, even we can distinguish them, then this is called the loudness of the sound. So loudness of sound depends upon the amplitude. The sound of same intensity may have different loudness. Different loudness for different listeners. So this sound loudness is closely related to to the intensity, but this is not the intensity. The loudness is closely related with intensity. But not equal to intensity. Suppose we are having this waveform. This is now 0. Here we take the displacement. This is now your time t. This is now like this 0. Here we have t, here the displacement. And suppose we are having another wave. Like this. This is suppose 0, this is now you are having displacement. And this we are having the time t. Then this is of large amplitude. This is low loudness. Low loudness. This is high loudness. High loudness. So here we are having the more amplitude in comparison to this one. So this sound is of low loudness and this sound is of high loudness. The unit of loudness. Of loudness. This is now phone. P-H-O-N, phone. Now there are so many sources which are having very high loudness and having a very low loudness. So the sources of high loudness. Sources of high loudness. Like this tabla, drum, and loudspeaker. Loudspeaker and school bell. and we are having this the roaring of loin, trumpet, etc. These are the sources of high loudness, and the sound from these can be heard over a long distance. The high loudness sound of high loudness can be heard over a long distance. Similarly, we can have the horn of the vehicle moving on the road, or suppose the horn given by that is blown by the train, that is also have the very high loudness. We can hear these sound over a long distance. Sources of low loudness. The sources of low loudness are the musical instruments, like sitar, guitar, etc. They are having a very low loudness. Voice of children and women, buzzing of bee, mosquito, hornets, etc. So these are the sources of sound which can be heard only when they are close to the listener. So the sound which are having the very high amplitude have the very high loudness, and the sound which have the low amplitude have the low loudness. So if the frequencies of these two is also different one, the high loudness means the low frequency and the low loudness means the high frequency. So that as the frequency increases, the shrillness of the sound increases. So that can be heard only when the listener is close to the sound source. The sound of low loudness can be heard only when listener is close to the source. This sound is closely related with the intensity, but that is not equal to the intensity. So here I will tell you there are some factors upon which this loudness depends. The loudness cannot be measured, so it is subjective. Subjective nature. Now, the factors affecting the loudness. The factors affecting the loudness. Now there are some factors which affect the loudness of the sound. Number one, the area of vibrating body. Vibrating body. Now, larger the area, more is loudness. It means that loudness is proportional to area. Is proportional to area. This is why that the tabla and drum, they are having the large area. So when they are beaten, then the loud sound is produced by them. So this example, tabla and that drum and that we are having the loudspeaker. Loudspeaker, etc. And now number two, the distance. Loudness follows inverse square law. Inverse square law. It means that this L is proportional to 1 upon R square. So as the distance between the sound source and the listener increases, the loudness decreases. So it shows larger the distance between listener and the source, sound source, less is loudness. So loudness decreases with the increase of distance. And number 3, the amplitude. Amplitude. The loudness is directly proportional to the amplitude. The loudness is proportional to the square of amplitude of the wave So what that this loudness is proportional to amplitude, its square. So this is proportional to A square. And now fourth factor, the density of medium. Density of medium. Higher the density, of medium, higher is the loudness. Higher is the loudness. Higher is the loudness. And if low is the density, low is the loudness. And vice versa. And now fifth is the presence of resonating objects. If resonating objects are present near the sound source, the loudness increases. The loudness increases. So these are the factors upon which the loudness depends. And that, as I told you, that this loudness is closely related to the intensity. So this is necessary to tell you about the intensity of the sound. Intensity of sound. The intensity of the sound means that what are the factors that affect to this one. So intensity is simply the rate of sound energy passing through unit area perpendicular to the direction of propagation. Of the sound wave. Of the sound wave. So this intensity equal to energy upon area into time. So intensity denoted by I, this is now E upon A into T. So this is measured. Now the unit, this is now joule per second into meter square or joule s minus 1 m minus 2, and this is also written as watt per meter square. The joule per second, this is the watt, the power. Now this intensity can be measured. So this is the objective nature. Intensity is a measurable quantity. So it is objective nature. Objective nature. Objective nature. Now the other units of this intensity are other units of intensity. Now this is your bell or decibel. Decibel, dB. Bell, this name has been taken from the name of the scientist Graham Bell, who invented the telephone. So this one bell is equal to 10 decibel. So decibel is a small quantity and bell is a big quantity. The unit bell has been taken from the name of a famous scientist. Graham Bell. Graham Bell, who invented the telephone. Who invented the telephone? So now I told you that the unit of the loudness is phone, so that here the phone and this decibel are the same one. The unit of loudness phone is same as decibel, dB. Now the factors that affect this intensity are the factors affecting intensity. Now, number one, this is directly proportional to the square of amplitude. Intensity is proportional to the square of amplitude of the wave. It means that I is proportional to A square. And now second, frequency. Intensity is proportional to the square of frequency, so that this I is proportional to N square. And third, the density of medium, the intensity is proportional to the density of medium. So the wave having the higher frequency will have the higher intensity, and having the low frequency have the low intensity. So this we can see that when the intensity is very high, then the frequency is very high, then intensity is very high one. You can see that if frequency is doubled, then intensity becomes 4 times. If frequency is tripled, then intensity becomes 9 times. So here also, if the amplitude is doubled, then intensity will be 4 times. Amplitude is tripled, then intensity is 9 times. That amplitude is 4 times, then intensity is 16 times. So thus intensity and this amplitude and the frequency affects the intensity to very much. And here this density, as the density of the medium decreases, the intensity also decreases. So you can see that nowadays it is the winter season, the density of the medium is more, so a small sound can be heard over a long distance. So that intensity increases due to the increase in density of the sound. And now fourth factor is so here we have the intensity I proportional to density. Proportional to density. And now fourth factor upon which this depends, the velocity. Velocity of sound. The intensity is proportional to the velocity of sound. So I is proportional to V. So these are the 4 factors upon which the intensity depends, and if these factors change, then intensity will change. So this is what about the intensity of the sound. So this loudness and intensity of the sound are closely related with each other. The minimum intensity that can be heard is 1 kilohertz. Minimum audible frequency equal to, this is 1 kilohertz, or this is equal to 1000 hertz. This we can listen, and this corresponds to the intensity. It corresponds to the intensity of 10 raised to the power minus 12 watt per meter square. It means that the intensity of this so much is equal to 1000 hertz. So this is the minimum audible frequency, and this is the frequency which this is the highest. This intensity corresponds to this value of the frequency, that is 1000 hertz. So now I will tell you the relation between the intensity and the loudness of the sound. Weaver and Fashioner law. This law gives a relationship between loudness and intensity of sound. They give the empirical relation between them. According to them, the loudness is proportional to the logarithm of intensity. It means what? That this L is proportional to log 10I. So this L equal to K log 10I. Now where K is constant, where K equal to constant. So now from here we can have the ratio of these two intensities. For I equal to I1, this L1 equal to K log 10 I1, and for I equal to I0, this L2 equal to K log 10 I0. So L equal to L1 minus L0. This is now K log 10 I1 minus K log 10 I0. Or this L equal to K log 10 I1 minus log 10 I0. So this is now K log 10 I1 upon I0. This is now so much. This is equal to L. So now then this we can write down this L equal to log 10 I1 upon I0 for K equal to 1. So we can take it now, this 10, this is not so much bell, so so 10 log I1 upon I0 into 1 by 10 bell. So this 1 by 10 bell is decibel. So this is 10 log 10 I1 upon I naught into this, so much is decibel. This is not relation. Where dB or decibel equal to 1 by 10 bell. So this is a required relationship. This I naught refers to minimum intensity. Minimum intensity 10 raised to the power minus 12 bar per meter square for frequency 1 kilohertz. 1 kilohertz. 1 kilohertz. Now we can see from here that if I1 is equal to I naught, I1 equal to I naught. So now for I1 equal to I naught, then L is equal to 0. It means that when the given frequency is not is equal to the minimum frequency, then loudness will be 0. And for I1 equal to 100 I naught, then L is equal to your 10 log raised to power 10, and this is now your 100 I naught upon I naught. This will cancel, so this is 10 log 10 raised to power 2. So this is now your 20 decibel. Similarly for I1 equal to 1000 I naught, or this is 10 raised to the power 3 I naught, then this L is equal to 10 log 10 into 10 raised to the power 3 I naught upon I naught. So this I naught will cancel here, this will also cancel. So this is now your 30 decibel. This is equal to L. So as the value of I1 increases more than this I naught, then the loudness of this sound increases. So you can see from here that if L equal to 1 decibel, now here the decibel and phone are the same. So either we write down this decibel or write down the phone, that is same one, but the more prominent unit is decibel. So we write it to be a decibel. For L equal to 1, then now you use this formula, then L equal to 1 10 log 10 I1 upon I naught. So this is now 0.1 log 10 I1 upon I naught. Now then I naught I1 upon I naught equal to anti-log 0.1, and this I1 upon I naught, this is now 1.26, or this I1 equal to 1.26 into I naught. So So this we can write this I1 is equal to, this is 1 plus 0.26 into I0. So this is I0 plus 0.26 I0. So this is I0 plus 26% I0. This is equal to I1. It means that when the intensity increases by 0.26 of the minimum intensity, then the loudness will be 1 decibel. If intensity of sound increases by 26% of its minimum value, the loudness will be 1 decibel. So this is what the relationship that shows you that how much intensity must be increased or the minimum intensity so that the loudness is equal to 1 decibel. So this is the should be increased by 26% of the minimum intensity. So this is what that we have the value of this I1 when the loudness is 1 decibel. So this is the relationship between the loudness and the intensity of the sound. So they are very closely related with each other, but they are not equal to each other. Intensity is different from that of the loudness. So this is all about the loudness and the intensity of the sound. So thank you very much.